If you zoom in 10 billion times, you'll encounter the atom. The atom is the smallest building block to all matter in the universe. The idea of the atom has been around for many centuries, but it has not been widely accepted for over 2,000 years. There are many important discoveries and experiments that have given us a better picture of what the atom looks like. Today you'll learn about the history and the discovery of the atom. Around 400 BC, an ancient Greek philosopher by the name of Democritus first proposed the idea of the atom. He believed that the atom made up everything in the whole entire universe. So take cheese, for example. If you cut up a mound of cheese in half repeatedly, eventually you come to the smallest part of the cheese. This would be considered to be the atom. Unfortunately for science, a much more prominent Greek philosopher at the time disagreed with the idea of the atom. Instead, he believed that the whole entire universe was made up of just 4 classical elements: earth, air, wind, and fire. And this idea stuck around for over 2,000 years. Fast forward a little over 2,000 years, and you start to see modern experiments that led to the discovery of the atom. It started to piece together the puzzle and what the atom looks like. So the first experiment that we want to discuss is the William Crooke's Cathode Ray Tube experiment, which led to the discovery of the electron. Let's see how he did it. The cathode ray tube is basically a glass tube that has been vacuumed, so all the air has been pumped out and replaced with the gas. And what William Crookes did was he excited the gas with electricity, and at the end of the tube there was a fluorescent screen, so he could see where the gas was hitting. Okay, but a part of his experiment also involved applying some sort of electric field to the tube. So he put these plates around the tube, and he noticed that it would bend towards the positive plate. So the gas is attracted to something that's positive. So because opposites attract, he inferred that electrons made up this gas. And you could also repeat the experiment with magnets, because magnets are related to electricity. So the point is, this experiment demonstrated that there's something in the gas that has a charge, and you can infer that it has a negative charge because it's attracted to the positive plate. So what you're looking at there on the screen is an early model of the atom. This was known as J.J. Thomson's plum pudding model. Plum pudding is a British dessert, which not a lot of people are familiar with. So sometimes this model is referred to as the chocolate chip cookie model, where the chocolate chips are like the electrons, and they're scattered throughout the cookie dough, which is the big uniformly charged positive sphere. So this model was later rejected after Rutherford's Gold Foil Experiment, which we'll discuss next. In 1911, Ernest Rutherford came up with his Gold Foil Experiment to see what was inside of the atom, to determine its structure. So the setup was simple. He had a box containing lead, radioactive lead, which gave off alpha particles. I'll go over the details of alpha particles in a different video, but for now just understand alpha particles are 2 protons and 2 neutrons that come off things that are radioactive, so it just shoots off naturally. So Rutherford expected these alpha particles to just go straight through the gold foil. The plum pudding model has since been rejected, but at the time, Rutherford expected most of the alpha particles to pass through in a straight line, and this was because the electrons were evenly dispersed through the whole entire atom. During the actual experiment, Rutherford got back some really surprising results. He noticed that some of the alpha particles were deflecting at huge angles, and some of them were even coming straight back at him. He was quoted as saying it was like firing a 10-inch shell at some tissue paper and having that shell come straight back at him. So if you look right above me, you'll see how Rutherford revised the model of the atom. So instead of the plum pudding model, he proposed that the atom contained a dense, positively charged region, which we know of today as the nucleus, and it's surrounded by an electron cloud. So the reason why the alpha particles were getting repelled is because the nucleus also contains a positive charge, which is why it's bouncing off the nucleus, and you see it hitting at large deflection angles. And you can see there to the left of your screen, that's basically just a close-up view of what's happening near the nucleus. So if you have a nucleus which contains a lot of protons and they're positively charged, it's going to repel the alpha particles and cause it to bend or deflect at large angles. Thanks for watching Atoms Part 1, which was the history and the discovery of the atom. Now you could try the Rutherford scattering activity. I've answered most of the questions on the notes, as well as the Phet portion. So the most important thing to understand is the plum pudding model was later rejected because of what Rutherford noticed during the gold foil experiment, and that is the alpha particles were being bent at large deflection angles. Had the plum pudding model been correct, most of the alpha particles would just pass through in a straight line. So make sure you answer the rest of the problems and include an ID photo and the picture of the work you'll submit online. Thanks for watching, and I'll see you next time on Win Chemistry.